It's remarkable to think that this right here, sand or silica, is the main ingredient in glass, which is what gets processed into the major architectural element of any home, the windows. Okay, so it needs a bit of sodium carbonate, magnesium, aluminium and calcium oxide thrown in and cooked to over 1000 degrees on a 500 metre long furnace and production line, but essentially this is glass. And even more incredibly, that's just one of 100 or so processes that turns raw ingredients into the aluminium windows you see around you. And it quickly makes you appreciate why building a home is so expensive. This amazing journey of sand being transformed into glass is one of the most incredible processes any man-made creation can take. And that process all occurs at this Viridian plant. With its 500 metre long production line operating 24 hours a day, 7 days a week, this $200 million facility never sleeps and is the only manufacturing plant in Australia making glass. However, for such an amazing process, it all begins with a rather humble start. At these grates in the ground, where freshly quarried sand is fed into a system of silos and conveyor belts, along with dolomite, soda ash, rouge and recycled glass, that all meet at the start of this furnace.
Predominantly it goes into the back of the furnace. If we were to melt straight sand, we would have to melt at about 1600 degrees.
And here it's about 1300, I think, isn't it?
It is. Yeah. By mixing in broken glass, we gain some efficiencies with our furnace, so we can run it down to about 1300 degrees.
Wow, and so in other words, the sand starts the process there?
Yes.
And then it's going to work its way down the kilns?
So as it melts, it works its way down through the furnace.
Operating at 1300 degrees, this river of molten glass now flows downhill with a toffee-like consistency before it gradually makes its way into the bath.
What we've had is it's come through the furnace into our bath section. In the bath section, the glass flows over a lip and into the bath on a bed of molten tin. Now the molten tin and the glass are different densities, so the actual glass floats on the tin, and that's why it's called float glass.
With forces repelling this glass and tin, this oil and water style repulsion keeps the glass afloat, and while in suspension, top rollers begin pulling and stretching this now viscous glass to the desired thickness.
We use this equipment here, which are our top rollers, and that then stretches the glass out and pulls it through. That speed that it pulls it through gives you the thickness of the glass.
Okay, so 3mm glass would be stretched thinner than 10mm glass?
Yeah, and it will run through quicker.
With constant 24/7 monitoring of this process by the control room, this continuous ribbon is now being produced infinitely, varying from 2.5 to 12mm in total thickness.
It can be up to 1000 meters an hour on really thin glass, down to as slow as maybe 200 meters an hour on the thicker substances. We're firing something in the order of 4,000 cubic meters of gas every hour in that furnace. So our gas bill is something in the order of $500,000 per month.
And it's this continuous burning of the furnaces that not only makes for an incredibly expensive operation, but like all float glass factories around the world, it takes an enormous physical toll on the kilns. So this production line must be totally rebuilt every 15 to 20 years at a cost of around $50 million.
Around that period we do close it down, shut it down, and then actually repair the furnace. So we go cold for about 3 months, repair all the factories, mainly in the furnace, and then restart the factory, restart the furnace in a controlled fashion to get the temperatures back.
After this heating stage, the next 200 to 300 metres anneals the newly formed ribbon of glass through the leer, where hot and cold air is carefully oscillated to bring it back down to room temperature and harden the glass without ever thermally shocking or stress cracking the sheet. This sheet is next washed before being computer checked for bubbles, scratches or minute imperfections.
So it will look for any issues with the glass.
And it's computer processing every single detail of
Absolutely.
every little microscopic bit of glass.
Yep. And so then the computer then knows where that fault lies. It'll mark it in the next section. And then it will know it needs to cut that part out because it's no good for the customers.
So it's searching this continuous ribbon of glass the whole time.
Yep.
And it's managing to find a very minute bubble in the glass.
Yep.
It'll mark it, and then later down the line, that robot will cut that section out.
Absolutely.
The scrap glass is automatically cut out and diverted on an underground conveyor belt to be melted back down in the furnace, with the otherwise approved and quality checked pieces cut into big sheets and sorted into the different batching sections. These sheets are stacked and warehouse packed, where they are transported to the next factory to be turned into finished double glazed units.
If I come off, so you'd be 23.90 overall.
With this glass now ready to be made into one of the most glamorous and luxurious features of any home, being the windows, it was important to double check all of the measurements before anything was cut to size. With our fabricator on site for his first check measure, it was a good chance to run through the entire window schedule.
Door 3 is a sliding door.
Which is
Master bedroom.
running through the schedule at this stage and understanding how these window and door frames will be fixed and finished into the openings is key to the end look we're trying to achieve.
I think we're still better off putting a reveal on it and just keeping the reveal to like a minimum. Maybe we end up having.
With our carpenter on site to oversee the fine detail for the sizes and specifications of the frames, and with all of the measurements and finishes confirmed, the window order is placed. And to make way for these window frames soon to arrive on site, and with the concrete in these walls now cured to strength, it was time to remove these timber frame supports. After being carefully sledgehammered out, exposing the full size of the opening, these openings are next cleaned up and fine-tuned with a demolition saw, which, once complete, makes its way onto cutting out the rebates for the door frames in the concrete slab. With the help of a jackhammer on site, these rebates are carved out for the door frames to sit neatly into. The rest of the day was spent wrestling with this jackhammer, as it chisels and prepares this slab for the rendering in the weeks to come. The great complement to large spans of impressive glass is an equally impressive window frame. And it's at the AWS showroom and factory where our impressive frames are made.
Windows are more than just windows. There is a lot of innovation and design and research that goes into developing these windows and doors as you see the finished product.
And you have a lovely slide there, lovely rolling, very easy.
As simple and beautiful as these aluminium windows and doors look, they hide a complex system of Australian engineering and innovation. With these large aluminium billets first cut into 1 metre lengths, these pieces are heated. And after becoming malleable, they are machine pressed through a unique shaped die. Each of these dies is one of 1,500 or so AWS patented extrusion designs that altogether make up the component parts to the entire range of AWS window and door designs. A giant warehouse next stacks this expansive range of unique extrusions, which is categorised by an army of pickers and packers, who also batch up each individual order. With our order now made up, and after being chemically bathed through a 3-part dipping process, these now primed and treated lengths arrive at the colour spraying booths, where robotic arms spray each of the pieces, before they are finally oven baked to completion. Although our frames enter one additional and separate process, which creates a thermally broken or advanced energy efficient window and door frame.
It's essentially 2 frames that are extruded and zipped together to create the one unit. So you do have a thermal insulator through the frame, separating your external temperature from your internal temperature.
And it's this technology of thermally insulating our window and door frames that is essential to satisfying the strict energy rating regulations for all new home constructions.
If you're using a more energy efficient or higher performing window and door, you'll have that ability not to have to compromise so much on your design and reducing the size of your windows. So that's something that our thermally broken products are quite useful for, and that is not having to compromise as much on the size and amount of glazing on each elevation.
Having advanced energy efficient ratings means we don't have to compromise on the size or design of our window schedule to make it comply with building regulation.
It's the flow of your home, like where your windows are, where your doors are, what side they open to. It makes a massive difference that a lot of people don't really consider at the start when you're actually doing this kind of investigation. It's more after the horse is bolted, really, when it's actually in situ and you think, oh, I really wish that door was fixed and that door
And
opened.
a little bit hard after you've paid for it, it's gone in and...
Come back and see me.
With these now thermally broken extrusions loaded up, they travel en route to our local AWS fabricators.
Which way am I going?
Left through the front door.
And soon enough, fully finished window frames would arrive on our doorstep. And Dad's brother, being my Uncle Brett, was there to lend a hand too and provide some comic relief.
Actually, look at the lens and you look at him.
I look at him actually.
That's it.
Yeah. What are you looking at?
I said look at the lens and then look at him.
It's a bit confusing, isn't it? There you got me thinking.
He's missing all the footage of the windows.
As these frames are all carefully carried into position, the job of fixing them into the home would make it start. With a spirit level and packers in hand, a few screws and a keen eye, these frames are all drilled into place. Some additional help would occasionally be required too. Although the rest of the job was pretty straightforward for the carpenters, who would work their way through the home, one opening at a time. Thermacell polystyrene walls would be the only slight difference to traditional timber carpentry, with our sliding windows and doors in this part of the home being fixed directly into the concrete core. As these windows are fixed in, we nudge ever closer to having a fully weatherproofed home, completed over the coming weeks.
Yeah, we've got about 20.
So Chris, welcome to Viridian. We're going to give you a tour around today and we're going to go see your double glazed units being made.
Straight from the line.
Straight from the line, all the way from raw glass from Dandenong to a finished product.
And our actual units.
Your actual units, mate, they'll be coming off.
Beautiful. Show me around.
With our frames drilled in on site, the only piece missing now was the glass. And with our glass being the Lightbridge unit from Viridian, these premium double glazed units will provide maximum thermal insulation and noise reduction, and are the perfect complement to bathe our home in natural light.
The glass you're getting today is our Lightbridge unit. It's the top of the range double glazed unit that we're making. It's got a high visible light transfer, so it doesn't necessarily darken your room. It lets in a lot of the natural light, but it does reflect a lot of the heat from outside. So you're getting the best unit you can get.
This $20 million plant and its operations are extraordinary. And being a fully automated line of over 20 processes in all, this robotic system takes our blank sheet of glass and cuts each piece to size before entering the next processes to making a finished unit.
Is that reading the glass, is it?
So it's passing a light through the glass and looking for shadows on the other side, and that tells us whether there's marks or scratches or imperfections in the glass.
And at that stage there, you can pull it off the line and get a fresh
stop it, and we can recut it, so that we get the good quality from here on.
With the next processes automatically sorting the glass, our glass enters the kiln to be tempered into toughened units. A 3D scan then searches again for imperfections, with an additional check for optical distortion too, before the next stage of the journey, to be washed, then gas filled with argon for thermal efficiency, before being finally shut into double glazed units. With our new glass units stacked and ready to become a major architectural feature of our home, this same focus on creating light and bright, beautiful window-filled spaces is too commonly overlooked by many in the building industry.
A lot of things that builders are doing is actually decreasing the size of people's windows in their homes to get the energy rating that they need, rather than using smart glass and energy efficient glass and double glazed units to have a bigger window, let more light in and still meet the energy requirements of homes.
And small pokey windows seems to be a common theme in Australia, which is more about cost savings for the builder and lessening the headache of energy rating compliance, versus going the extra step and investing in Australian innovations like Viridian's Lightbridge technology to achieve a better designed home.
So for us here, we get great enjoyment out of seeing big windows. If that's going to have energy efficient glass in it, that's even better.
So lots of light filled spaces.
Lots of natural light coming into the home.
Okay then. See you, buddy. Glass delivery coming in about half an hour.
With our glass fresh from the cutting process walked into the home, each of these units, some weighing close to 100 kilos, are neatly fixed into their frame. With the glass in, our fabricators at Rosebud Windows complete the process by finely tuning all of the moving parts and balancing each of the sliding glass frames. At the same time as the glass is going in, the roof would slip into position too. With the box gutters riveted in, the job of next insulating the roof with a giant foil blanket would be necessary to help with our energy rating, before this well-oiled team lays these roofing sheets.
last couple of days, we just installed all the box gutters, laid the roof. It's taken us probably a day and a half to get all the roof down. We had a bit of a decent sized crew here yesterday, so we got the bulk of it done with some good weather. Finished it off today, so we're just measuring all the cappings up now, get them ordered, get it semi-watertight until all the external claddings are complete, and then we come around and put all the cappings on and get it 100% watertight.
With the sheet metal down, the other half of the process for this roof would be the tedious job of capping, flashing, screwing and waterproofing to get it 100% watertight, whilst also setting up the rest of the storm water drainage system. As this roof finally protects the home from the elements, unbeknownst to us, we were only around the halfway mark of the project. With the fine detail now, the longest and most physically and financially draining phase of the build to come. It's a pretty good view from up here, and it's amazing to think it was only a few months ago we were pulling off the roof to our little old beach shack. What a difference time makes, and a bit of hard work too. Anyway, I'm off, and it's time for me to find that pesky ladder. Next week, our home will be wrapped in cladding and render. The plaster will go on, and we'll see inside one of Victoria's oldest and most opulent mansions.